Welcome, everyone. Welcome to Programming and Driving Your Robot Over the Internet, where we'll give you a little bit of an insight of how your team might be able to control your robot over long distances. And for those of you who have been here already or been with us before, we'll show you the improvements that we have made since you were last here back in 2020. But for now, I'm a little interested. Could you guys enter your team number and what you overall hope to get out of this presentation? Oh, I probably should have clarified. I'll probably in chat. Yeah. Great to have you. All right, great. Well, I suppose we move on.
Hi, I'm Steve Cirilla. I'm a coach for Team 2220 Blue Twilight, and I've been on the team for its entire existence for the last 12 years. I've been a programming mentor as well as electronics mentor. So, for work, I work at the University of Minnesota as a programmer as well.
All right. My name is Ethan. I'm a junior at Egan High School, and this is my third year as a programmer for Team 2220. Now, before we move on, let's take a look at the problems that we faced in the past and what we're trying to do to resolve them. So for starters, everyone's been affected by COVID-19. I mean, social distancing limitations prevented teams from meeting up in full. Regulations are being rolled back, obviously, for some teams, but other teams still cannot meet fully, and they don't have enough members to do so. Plus, they don't get to interact with each other. They don't get to interact with the robots, or just straight up restricted from even meeting in general. But COVID isn't the only problem that we're still seeing today. Some teams are restricted through staff and on-hand members. Maybe they don't even have enough members to meet in person. And because of these problems, programmers can't test their code on the robots. They don't have the people to do it. And then there's limitations that are also preventing team members from testing and driving the robot. So overall, everyone is limited by the lack of members or maybe not being able to attend in person. And this is why we have provided a few solutions.
So what we looked at last year at this time, for those that remember, we did have a presentation last year. First of all, we looked at a way to involve our programmers remotely, and we did that through software called VNC. There's a server side and a viewer side. We'll talk about that some more. We'll talk briefly about some possibilities for remote robot driving as well through non-traditional approaches through the shuffleboard or keyboard controls. These kinds of things are theoretical in nature. We haven't actually done them, but they would require changes to your robot code. So finally, in order to introduce remote driving, we developed what we call our site-to-site VPN through the use of 2 or 3 Raspberry Pis, depending on how you set it up, using the free Raspberry Pi operating system, as well as the free OpenVPN software that you can install on that operating system.
Now, excuse me, before we continue on, let me introduce you to, or let me reintroduce the traditional ways that most teams operate right now. For now, driver station laptops are used for operating and programming the robots in person. And you have a few options or how you might control the robot. For example, you might use a wireless radio or Ethernet tether, which directly connects to the robot, or a USB tether, which also works to help control the robot. Now, these are the most basic ways that we'll see teams drive their robot using computers. Now, this isn't the only way, however. we'll see that other teams will choose to use GitHub to control the robot, or even to remotely program it. For example, before I start on this, I'd want to get a quick head count. How many of you guys already use GitHub and know about it?
I will say our first week here at Jumpstart, we did have a nice session on GitHub. So if anyone wants to circle back around to that video, I'm sure it is saved.
That's a good point. GitHub can be used for other non-software purposes as well.
Well, yeah. So in our example of remotely programming through GitHub, you would assume a few things. For one, you have Zoom, so video conferencing is available. Teams can talk to each other at least, or at least some have some form of communication. Next, they also have a textual programming language like Java, which is what a lot of teams use, and it's assumed that the robot code is stored and shared via GitHub. Now, if just to quickly summarize up GitHub for those who didn't see the video, GitHub is this massive online repository that can store code, which multiple teams can use to make changes to without while safely being able to not destroy the robot. Now, with this method, multiple programmers can make and deploy robot code changes remotely. So you don't necessarily have to be next to the robot as per traditional operation, and code deployment and testing will require at least one person at the robot site in general. And to control the robot, the driver station and driver also remain at the robot site for control.
So next, we're going to get into the ability to actually remotely control the driver station itself, not the robot, the driver station. And we introduced that capability through the VNC software I mentioned earlier. So using that, all of your applications that you're used to using on the driver station can be used from one or more remote laptops, students in other locations from home. You would use VS Code like we learned in the last session. You could also use LabVIEW. You're not going to have the capabilities of using things like GitHub, but you'd have access to the LabVIEW interface remotely when introducing VNC, so that you can actually do certain troubleshooting things on the robot and whatnot. But generally, our use of this has been through textual-based programming like Java. And of course, you can view robot status, enable, disable the robot. The one thing you can't do that's glaringly obvious is hook up your Xbox controllers or joysticks on your drivers. Well, I'm getting ahead of myself. Those are actually done at the robot site. So yeah, I'm getting ahead of myself on that one. One of the requirements for setting up VNC in this manner on the driver station is to have a second Wi-Fi interface, so that you can have the one devoted to the robot as you're used to doing, and then the other Wi-Fi interface is your connection to the internet from the driver station, therefore linking those people at home with the actual driver station. Let's see, and then you also have the option of tethering as opposed to Wi-Fi, which isn't quite as fun. The VNC software itself is out there. We have some documents in the folder collection we'll include at the end of the presentation. Instructions on how to set up both the server software on the driver station itself, as well as client software on the student laptops at home.
Now, VNC can actually be used in a couple cool ways. Now, like Mr. Strillo was saying previously, VNC can actually be used to control your robot without actually needing to be right by it. For example, you may use something like Shuffboard or Smart Dashboard controls. Now, if you don't know what these are, they're basically these, interfaces where you can control multiple elements of your robot at the same time. Using Shuffleboard and Smart Dashboard, you can actually control the robot with maybe sliders or buttons. And theoretically, you could implement keyboard controls for your robots using VNC. Now, we haven't exactly tested these. We haven't tested these methods yet. But from our knowledge, the robot code will need to be changed in order for this method to work. And like Mr. Solo was saying previously, with this method, you can't use USB devices like joysticks or Xbox controllers remotely. So you'll be bound to keyboard controls if you want to use this method.
So here we want to get to fully controlling the robot remotely through use of a VPN, which is the thing we really wanted to get to, allowing our drivers to use the driver station laptop they would use in person. And the driver station itself is then transported to a student's home, for example. It allows for you to remotely drive using all the standard USB, Xbox controller joysticks that you're used to using. This solution requires additional hardware in our solution. We use Raspberry Pi computers for that, as well as additional software, the Raspberry Pi OS and OpenVPN, which are freely available. The robot connectivity is via Ethernet tethering or wireless on the robot side, depending on whether tethering is something acceptable to you, or more likely wanting to go wireless, where you would add in a wireless router at the robot side. The beauty of this whole solution is that no hardware changes are needed on the robot or at the driver station, and that no robot code changes are needed. So you can basically run your robot and your driver station in two separate locations in the exact same way you would if they were in the same location.
Hey, Steve.
And pardon.
We just had a question whether or not tethering means that it's physically connected to a wire?
Correct.
Okay.
Tethering would mean you either use an Ethernet cable or you would use a USB cable, both acceptable. Often that's something that is required at an FRC event where you are not allowed to use wireless. So yeah, there would be a physical wire. So most teams are going to want to go wireless.
Because that's why it's not as much fun, because you simply can't go as far, kind of stuck.
Exactly. We do have a long Ethernet cable that we use at competitions when we're not allowed to do wireless. So yeah, it's a bit of a challenge with that cord hanging out, but it is an option.
Yep. Thanks.
And in the chat, anyone have any experience using Raspberry Pis? And while you're answering that, I'll go through this slide very quickly. Raspberry Pi OS and the OpenVPN software, as I mentioned earlier, are downloadable off the internet at no cost. And you install that operating system by writing it to an SD card, which gets inserted into the Raspberry Pi. Configuring the operating system initially, you'll need an HDMI monitor, keyboard, and mouse. Once you've configured it, you can access that Raspberry Pi remotely through things like SSH or even VNC itself. So there's actually multiple uses of VNC in this configuration. For those that were in last year's presentation, you might recall there were several steps in the process of installing and configuring an OpenVPN software. Since that time, we've created an installation script that can do a lot of the things in the background for you. It will prompt you along the way and give you suitable defaults. And yeah, usually you have 3 Raspberry Pis set up. You'll have a server, a VPN server set up at some site, could be any site. And then you'll have a Raspberry Pi set up at the robot side, and you'll have one at the driver station side. And let's see, and Nathan has some experience with the FRC use case. So if you do have experience, that'll obviously help you along the way. And I'll briefly cover the VPN server setup, although a lot of this, I'll point you at our website. We do have a pretty good instructional webpage for doing all this setup. We'll put in chat. So briefly, what's involved this year anyway is creation of a private GitHub repository, not to hold software, but to actually hold the VPN's configuration itself. And I say private because you don't want just anyone connecting to your VPN. And then you would take your first Raspberry Pi and set that up as the OpenVPN server, and you run through the setup script and answer the appropriate questions. That one is going to take a little bit longer than the clients to set up because of this private GitHub repository, but the clients are pretty simple and straightforward and quick to set up once you've set up the server. You can use wired Ethernet or Wi-Fi for your server side. I have mine set up in my home right now for our team, and I have it wired directly to my router for just for reliability's sake, but you can go Wi-Fi. This will require you to have a publicly accessible IP address, which is generally going to be your router, and it requires some changes which are described in our instructions to set up port forwarding so that the clients out in the world can connect to your server. And naturally, if your router changes its IP address, we have a means for you to change that through some other scripts that we wrote to update that private GitHub repository. So all the clients and servers are on the same page and can connect with each other. Of course, if you have a static IP address, that's great. That is true in our situation where this IP address doesn't change. The clients will always connect to that same IP address. All right. And then quickly, the driver station the driver station client. Once you've set up the server, you'll have another Raspberry Pi that you will run the VPN setup script for, and it will obtain the credentials it needs from the GitHub repository you created earlier. And takes about 5 or 10 minutes to run through this. And on the driver station side, you'll basically be connecting your driver station to that Raspberry Pi with an Ethernet cable, much the same as you would in a FRC competition. And then you configure your Wi-Fi interface on the Raspberry Pi to your ISP router, to your router that goes out to your ISP. So that's pretty straightforward. And then likewise, on the robot side, which is in our case at our school, you'll do the same thing. You'll bring a Raspberry Pi there with a Pi OS and run the setup. And in that situation, your Ethernet cable is going to plug from your Raspberry Pi directly into either your robot's radio, if you're going to choose the tethering approach, or better yet, it's going to plug into a wireless router, which in turn will be configured to talk with your robot in a similar way to how it would in a competition. Yeah, and then you would configure the Wi-Fi interface so that it has internet access. All right. I've talked enough. I will turn this over to Ethan next.
Now I guess we'll be talking about the how you might stop the robot if your robot decides to go crazy while you're controlling it over the internet. And there you have a few options here. For starters, the remote controller or remote driver could easily press the space bar, which is the normal emergency stop capability built into the system. However, when that fails, you also have a few fail-safes. For example, you'll by disconnecting the Ethernet cable from the Raspberry Pi, it severs the tie between the driver station and robot, causing an auto disable. You can also disconnect the Ethernet or power cable from the robot wireless router. In this case, it will result in the same result, where it will auto disable when it's unplugged. Now, to show this capability, we actually have a little bit of a demonstration from when we were testing it with our team in Poland.
This There's this Ethernet port here, so you just squeeze down on this and then pull it out. And that's just going to stop like any connection.
And the reason it stops it is because the robot's not getting any keep alive or watchdog stuff anymore. So it automatically shuts down at that point.
Yeah,
So this is fail safe.
that's if you like she's a robot trying to go through and go.
Everybody hear that? Good. I just want to make sure the audio worked on that. We have a couple more videos.
Okay, great. Now, to really quickly summarize exactly what Mr. Searle had been saying, we actually built a little diagram for you guys to look at. For starters, I think you might need to click it first. For starters, you have the server site a VPN server, which is basically what is going to allow all your internet connections to converge on this server. Basically hosts all the VPNs, the Raspberry Pis, and connects them through this one server. Next, you have the robot site, which also has a robot VPN. Now, in this case, you have a few options here. So obviously, you have your wireless router, which connects to the robot VPN client, which connects to the robot radio. Now, as we were saying before, you could tether the robot VPN client directly to the robot radio so you can make direct connection. However, because it's severely limited and not necessarily the most efficient, most teams will most likely prefer a wireless router option directly to the radio. As we see, the robot radio is again connected to the Robo Rio, which controls the robot and allows you to view cameras, which I'll show you demonstration later in the video. Now, on the driver site situation, where the person actually controls the robot, they will also have a similar setup where they will also have a Raspberry Pi VPN client, which directly connects to the internet and VPN server. Except the setup's a little bit more simple. It's just a computer, and you can actually attach a USB controller to it, unlike how we were talking about in VNC. All because of its wireless connection to the internet.
So I'll briefly run down the kind of hardware we're talking about being needed to set this up. There are scenarios where you could get by with maybe 1 or 2 Raspberry Pis, but I'll get into that at the end. In the general configuration that we've run, we have 3 Raspberry Pis total. I should also note that the prices mentioned here are for the most part accurate. However, you'll notice the comment on the bottom talking about chip shortages and the current costs. I went on recently looking at Raspberry Pi 3B to verify that they were indeed still around $35, $40. And to my surprise, I couldn't find anything under $85. So that will increase your costs if you don't already have some Raspberry Pis available. You can, of course, use Raspberry Pi 3B or the more recent Pi 4. Both will work fine. We would suggest if you are using these in students' homes and at the school, we want a little more protection around the Raspberry Pis. There's a case that we have linked later when you look at the presentation. I think these are turned into links. We also have a document in our document collection with this slide essentially. And of course you need a power supply and an SD card for each of the Raspberry Pis as well as Ethernet cables. Beyond that, if you choose to not have to tether your robot during the VPN, you'll need a wireless router and cable, running around $40. For initial setup of each of the Raspberry Pis, you'll need an HDMI monitor and you'll need a USB keyboard and mouse. And once you've done that initial setup, you can choose to configure the Raspberry Pi so that you can access it remotely after that. Or you can continue to use your keyboard, mouse, and monitor. And of course, on the driver station that you choose, you're going to need an Ethernet port to connect to the Raspberry Pi and access to the internet, obviously at the client locations.
So real quickly, we also recorded a few demonstrations of the robot VPN in work in progress. So this some of these videos and photos were taken on the growth of during the growth of the COVID pandemic. A few were only allowed on site, and so this was the only options we really had for testing. So many of you might actually be wondering what exactly it was like to control the robot over the internet, because you might be asking, oh wow, the this huge complicated VPN setup might cause a lot of ping advantage. No, it might cause a lot of lag and disconnections. Well, we actually discovered that it was quite the opposite. In the video, you actually see that the ping is relatively low, or the delay is relatively low. It was really easy to control. So I had a lot of fun driving it from the comfort of my my bedroom. That was pretty nice. And in general, the camera feed was not laggy. Contrary to what a lot of people would probably believe, as using a bunch of bandwidth, it was not laggy. I could see really clearly. If you just move on to the videos, you can actually see me drive the robot.
There's no audio on this one.
Now, if you just look between the top right and bottom left screen, you'll see that there's basically no difference between how I would normally drive it in person. It's really difficult to tell. Another disclaimer I will also have to make out is that we did not end up using the school Wi-Fi. At the time, for some reason, we were having issues. Although these were eventually resolved, we resulted in using a cellular internet service provider instead, just for the convenience. And even then, it still had relatively low delay. And again, it can carry out all the functions a normal robot can carry out. In the next slide, we actually show you it can shoot the balls that we programmed it to do. And so yeah, basically no problems. And it was really an interesting experience being able to control the robot from the comfort of your home. It's pretty nice. I can't lie, and it was certainly fun. Actually, we have had better. We've had one time it was like 0% packet loss because we were using a Wi-Fi service provider, right? It was like really low.
In a perfect situation, or I shouldn't say in a typical situation, you should be able to have no packet loss. But because we were using a mobile provider, and yeah, that was the main reason we were having some of that packet loss. But even with that packet loss, you saw a pretty smooth driving experience nonetheless. So it can withstand some packet loss.
Yeah, and on the impact of the robot, impact of the movement, really there when the packet loss was like 0, there was it was really difficult to tell the delay. Of course, you can't prevent all the delay, and so some of the controls were slightly off time. But for the most part, the controls seemed smooth. They didn't really cause me any problems, and especially for our team in Poland, it didn't seem like they were running into any problems either. So we've actually tested the robot VPN over or internationally through our teams in Poland. They have actually been able to drive the robot all the way from Poland to here in Minnesota, and that was really fun to watch.
Getting used to, I imagine.
Yeah, the robot is gonna turn a lot faster than it switches screens. Yeah.
This is at our school.
Yeah. All right. Go ahead.
And the driver's in Poland.
Yeah, like turning is hard.
Turning is gonna get faster when you increase the speed.
Oh,
Initially, you want to go with wider turns until you can get the hang of it.
And that was the first time he had ever driven our robot, was over the VPN. So he had a little trouble, but only because he had not driven our robot before. Whoop, sorry.
Oh,
I'll get that back. All right. Still seeing my screen, right?
Yep,
Oh,
still
yep.
see it.
Okay.
cool. So one thing, another thing that we have been trying to test in the past was utilizing both the VPN network and VNC to allow students to control the robot. So in this scenario, we would be controlling the robot over a robot VPN, but then multiple students using VNC would be connecting to the driver station VPN, allowing multiple students to access the driver station remotely. In this case, students could also take turns controlling the driver station while others would need to view. Now, the driver station wireless interface does need to be enabled, and this would allow the driver station to be reached through the internet through VNC. So it would need both the connection to the VPN and a connection to the internet.
So some of the improvements we'll note here that we made pretty much last winter, last April timeframe, had to do with eliminating manual steps that were kind of tedious and error prone, as well as having to use an editor to update the configuration file. So now we have these installation scripts that kind of take care of a lot of that for you and just ask you some basic questions that have suitable defaults. And then we save that configuration into a central GitHub repository. So we have an easier client setup, and future the commands that we provide all are able to use that information to give you the best and easiest experience. It determines your router's public IP address automatically, for example, and it makes for changing your server IP address, if your router changes, easier as well. We reduced the total installation time from hours to under 45 minutes for the Raspberry Pis, and the server generally takes a little longer. It takes about a half an hour to set up once you've got the Raspberry Pi OS, written and running. And for the client setup for the VPN software and configuration, it takes literally 5 to 10 minutes. So yeah. And then we added a couple of commands, one to test out the VPN, which I'll show the output of shortly, to help in troubleshooting. We added a command to uninstall, should you choose to want to get rid of all the software that we installed for the VPN and the configuration. That's easily done as well. Or if you simply want to start over. Has anyone in the chat, has anyone used VNC or our robot VPN solution in the past year? And while you're answering, I'll give you a look at the output from our VPN testing script. As you can see, the first 4 lines, pretty much the configuration information that we store to allow access to our private repository. And then everything down below that is pretty much the status of our various devices that are on the VPN. You can see our team number 22.20 is embedded in all of these. Your team number would make for different IP addressing, pretty much what you're used to currently. And then there's some VPN specific addresses in the higher range there. And it tells us what role we are on that Raspberry Pi, etc., and your public IP address. And then it goes through and basically does a ping on all the possible devices. In this case, the VPN server was the only thing up because that's where I ran this from. Everything else it was claiming is unreachable. So it's good in troubleshooting your VPN to be able to run this and have it tell you at a glance. And then finally, there's a log file that's maintained for the OpenVPN software that will give you information on who's connected recently and who's been trying to connect. In the case of the TLS errors, those are basically systems out there that probe around and try to get into various ports, do port scanning, and due to the security that this solution provides, they have no way in without that security certificate. And this is basically saying someone tried. So I guess I'm not up to date on my chat. 5 new messages. Can you get better than 4.4% packet loss?
Oh yeah, I answered that before.
Oh, so you've already covered these. Okay, good. Yeah. Moving along here, we have just a couple more slides here. Combined VPN server. Okay, so this basically just covers, I'll let you kind of read through these. This is kind of what we anticipate as possible future enhancements going forward. Either to reduce the number of Raspberry Pis that you need on the first 2 items, or to expand the use of your VPN from being team specific to maybe a multi-team configuration. It's something we've been anxious to try, but we have not, we've not done so yet. And then there's of course the possibility for adaptation for use with FTC. And I don't know how many of you here are here for FRC versus FTC, but we haven't done a lot in that area as of yet. And then there's an FTC slide here, which, you know, I don't know, again, if anyone's here for FTC or is familiar enough with FTC, but I'll let you read that on your own here. And if you have used this teledrive solution, it's another alternate solution for doing something similar, remote driving of FTC robots. Throw it in the chat. And with that, if anyone has any questions, this is a great time either unmute or type it in the chat. And I will be providing in the chat myself some of the links that I had alluded to earlier. And they also appear on this slide as well. Now, if I can find my links. There we go.
Is this useful in a pre-COVID application? Pre-COVID? I certainly believe so. I don't know if you mean like post-COVID, like after this whole thing ends, but most certainly, yes. Even teams that can't meet up because of the lack of members on site or inability to actually be able to have access to the robot, this robot VPN will still be able to provide access to those who are encoded, you know.
I don't know if everyone caught all of that because you cut out for a minute, Ethan.
I'm sorry, my Wi-Fi has been a little iffy. But yeah, if I wanted to, just to restate what I was saying, even some teams, or even if your team is just interested in this in general, and you don't necessarily want to have to go to site to test out the robots, or maybe you want to have some people who can't come to school to test the robot because of pre-existing conditions. Okay, cool. Was curious if this is useful aside from the pandemic. Yeah, it is. Yeah, it's certainly still useful aside from the pandemic. Like I was saying, if you wanted to test your robot without needing to come to school, Or if you didn't have enough members, some person was across the world and they wanted to get some experience with driving the robots, like they maybe be on vacation or unable to attend in any way. This robot VPN will be able to provide them access to it without needing them to actually come back. So let's say you're in Hawaii, you want to drive the robot, don't have to fly back to your state just to drive the robot, you know. So it can be used in a few different ways.
That sounds pretty handy. Don't have to come back from vacation. Nice. Very good. All right. Any other questions?
I have a
That was
couple more.
very interesting. Go ahead.
Oh, sorry. I just have a couple more slides. You can see
Oh, okay, good.
our setup, our Raspberry Pi use of on the robot VPN client side with a little monitor there and keyboard mouse. There's the back of what that monitor actually houses the Raspberry Pi. Different than the solution that we described, but yeah, just a couple of bonus photos.
Nice, very good.
Thanks for coming, everyone.
Thank you
Yeah.
for joining us.
Thank you,
Yeah.
Ethan, Steve. Appreciate it. Appreciate your time. It's very interesting presentation. I always learn something from these.